Okay, here's warm up 9.6. I'm going to solve for x on all of these problems. Let's see. On the first two problems, I've got a right triangle that's split into smaller right triangles. Okay, so it turns out this big triangle, the medium triangle, and the small triangle are all going to be similar. So you can write a proportion by figuring out which pieces match up and solve this that way. But that can get a little tricky unless you draw the triangles separately, which you can definitely do, but it takes a little while. You can also do this, though, with geometric mean. So geometric mean, the little formula for geometric mean, the geometric mean between two numbers is going to be equal to the square root of those two numbers multiplied together, the square root of the product of those two numbers. Okay? So, when you're dealing with the altitude of the big triangle, which is the 12 is the altitude or height of this big triangle, the height is going to be the geometric mean between the two parts that the hypotenuse of the big triangle is split into. So in this problem, 12 is going to be the geometric mean between 9 and x. So 12 is the geometric mean between 9 and x. So I'm going to start like that, okay? And I want to solve this for x. So I'd like to get the x out of that square root symbol, and I can do that by squaring both sides of the equation. Okay, so 12 squared is 144. And the square and the square root undo each other here, so this is just 9x then. And then I'm pretty close to solving for x. So I'm just dividing by 9. X is going to equal 144 over 9. And 144 over 9 actually comes out to an even 16. So x is 16 there. Okay. All right, this next one's a little different. So the mistake on this next one, this is wrong. So heads up, some people are going to say, oh, x is the geometric mean between 9 and 16. I totally understand because that's kind of what we did on the last problem. But this is wrong because we're not dealing with the altitude of the big triangle. We're not dealing with this segment in the middle of the triangle like we were on the last problem. We're dealing with a segment on the outside of the triangle. So this is one of the legs of the big triangle. So this is a little different. X is still going to be the geometric mean between two things, but it's not going to be between 9 and 16, okay? Because that would be this segment, and this segment's going to be shorter than x, okay? So this is how it works. X is going to be the geometric mean between the short piece. Here, I'm just going to write a little formula here. And the whole thing. Okay, and I'll explain what I mean by the short piece and the whole thing. Sorry, not the short piece. The close piece is what I mean. I don't want to start the whole warm-up over. Made a little mistake. So, yeah, don't get too mad. Sorry, I make mistakes sometimes. So the close piece, I mean the close piece of the whole hypotenuse. So this would be the close piece. So that just means it's closer to the x than the 16 is. Okay, this one's farther away. And the whole thing is going to be the whole hypotenuse, which is not just 16. 16 is the right piece, 9 is the left piece. So if you add them together, that means 25 is the whole hypotenuse. So x is actually going to be the geometric mean between 9 and 25. Okay? And let's see, 9 times 25. I think this is going to come out to a perfect square here. I'd want to put this in simple radical form, but it turns out 225 is a perfect square. 15 times 15 is 225. So x is going to equal exactly 15 here. Okay. Whoops. Sorry for my mess up there. Okay. Next problem. These three problems I've got, these are not special right triangles. They're not 30, 60, 90s, not 45, 45, 90s. I can't use Pythagorean theorem on any of these because I only have one of the three sides. But I can use SOHCAHTOA. Okay, so I'm going to use sine, cosine, or tangent. So here's the little acronym, very useful when figuring out whether you're going to use sine, cosine, or tangent. So in all these problems, you want to think of yourself being at one of the corners of the triangle, and you're going to be at the acute angle that is marked. So I never want to be at the right angle. I want to be at the acute angle that is marked, so that means I'm at the 63-degree angle here. On the next problem, I'll be at the 16-degree angle. Last problem, I'll be at the 48-degree angle. Okay? And then I'm thinking, which pieces of the triangle am I dealing with? So I've got the hypotenuse, but then I've got legs. I've got an opposite leg and an adjacent leg. So 10 here is the hypotenuse. Okay, x is going to be one of the legs, and I'm thinking, is that opposite or adjacent? Well, adjacent would be next to me right here. That's unmarked. That one's across the triangle, opposite. Okay, so that's going to help me figure out which of the three pieces. So I'm looking for one that uses an O and an H, and the opposite and the hypotenuse. That would be sine here. I have to use sine. So I'm going to say sine of, I want to say where I am. I'm at the 63-degree angle. Sine of 63 is going to equal opposite over hypotenuse. Opposite over, so it's the first letter over the second one. So x over 10 here. Okay. I'm going to set up problems 4 and 5 first before I solve number 3. So here, x is going to be the hypotenuse, always across from the right angle, right? This time this is an adjacent leg down here where the 13 is. It's next to me. The opposite leg would be over here. So I've got adjacent and hypotenuse. The only part of SOHCAHTOA that uses adjacent hypotenuse is cosine. So this is going to be cosine of 16 degrees. And I'm going adjacent over hypotenuse because that's the way it's spelled there, right? A over H. So that would be 13 over X. Okay, and then the last problem, let's see, I've got opposite leg, and this is adjacent leg. The hypotenuse is unmarked, so this is going to be the tangent part. Got one of each here. So tangent of 40, I'm at the 48-degree angle, opposite over adjacent, x over 12. Okay, so we still have to solve all three of these for x. So first I'm going to start isolating the x in all three of these. So opposite of, I want to get the x by itself, opposite of dividing by 10 would be multiplying by 10. Don't multiply the 63 by 10, right? You want to put the 10 out in front of sine of 63 degrees. Okay? Okay, so from there, I would need a calculator. So you want to be in degree mode, which I am here, because my angles are in degrees. So on my calculator, I can just type in 10 sine of 63, like that. You could also take sine of 63 and then multiply your answer by 10. Either way is going to get you to about 8.91. I'm going to go to the nearest hundredth on these. And I like to think about my answer and see if it kind of makes sense. It seems like 8.9 would be pretty reasonable if this one's 10. I know it's going to be smaller than the 10. But you know, if you get numbers that are way off the other sides of your triangle, maybe there's a mistake. I kind of like to double check that. Okay. Next problem. A lot of times I see people multiply both sides by 13 here, but that's not going to isolate the x. So if I multiply by 13, I get 169 over x. I don't want that. That's not going to do anything. Okay. So what you can do is multiply both sides by x, and then the x would be over here, and then you could divide by both sides by cosine of 16 degrees. That works fine. Or you can use my little maneuver in this situation when the variable's on the bottom of the fraction. So you've got something equal to a fraction with a variable on bottom. You can use what I call the incredible switch. You can just switch the position of those two things. It's not going to save you tons of time, but it saves you a step algebraically. And that's where we're going to end up if you were to multiply both sides by x and then divide by cosine of 16. Okay? So time for my calculator, and some calculators might want to do cosine of 16 degrees first and 13 divided by whatever that decimal is. On my calculator, I'm just going to put it in exactly as it's written here. Again, I'm in degree mode, so I got about 13.52. Okay? Now, last problem here, you could do incredible switch, but that'll just say 12 equals x over tangent of 48 degrees. It doesn't isolate the x, right? So I don't need any incredible switch here because here I can just multiply both sides of the equation by 12. And now x is isolated. So, okay, x equals 12 times the tangent of 48 degrees. And need my calculator again. 12 tangent of 48 degrees comes out to 13.33 roughly, rounded to the nearest hundredth. Okay, that seems to fit pretty good with the 12, right? On the last one, 13.52. Hey, I knew the hypotenuse was going to be longer than the leg, so those numbers all feel pretty reasonable. Okay? All right, that's the end of the warm-up, and I will see you next time.